Hello and welcome back. Today we have 209 minimum size subarray sum. It says here that given an array of positive integer nums and a positive integer target, return the minimal length of a subarray whose sum is greater than or equal to the target. So it can be greater than. If there is no such subarray, return 0 instead. All right, so we're given three examples here. I'll start with the third one where we have 8 ones and our target is 11. Here, even if we were to sum the entire array, we would not have a value greater than or equal to the target of 11. So in this case, we would return a 0. All right. Also, we have the second example here where the target is 4 and we have options 1, 4, and 4. Well, 1 and 4 combined, along with 4 and 4 combined, along with all three combined, are all greater than or equal to 4. Basically, any combination excluding 1 by itself. However, we do want to return the minimal length of this subarray, so we want to ideally return 4, as in 1 representing the 1, 4. It can be this one or this one, because that is the minimal length of the subarray whose sum is greater than or equal to the target, which happens to also be 4. All right, so I think we covered these two, so let's get on with the main one. Here we have, let me add some indices here. All right, I hope they are in view, 4, 5, and our target is 7. We can already see just visually that these two combined would be the minimal length, but how would we do that with code? Well, we can do it in one pass actually by maintaining a sliding window. So we always have a start. Let's call that L, and we iterate with our right pointer. So for every iteration we reach a certain number, we add that to our total. So our total is currently 2 by itself, and 2 by itself, let's call that the S for sum, is not greater than equal to target, so that's all right. We move our right pointer forwards. By this point, we can add 3, so this now becomes 5, which still isn't greater than or equal to our target, and that's all right. Let's move on. Now we're on index 2, which has value 1. Add that to our sum over here. We have a 6. We're getting close, but not quite greater than or equal to our target. So let's continue. Now we see here we have a 2. When we add this 2, we're finally greater than or equal to our target. We can see that this is 4 numbers. We can also get that by subtracting the starting position from our current position. So right minus start, here we go, and because this is 0 indexed, we add a 1, and that combined gives us 4. Okay, so let's make some room. So now we have one potential result, which is 4. So why don't we have that as a result and say, hey, this is a potential result. Okay, at this point, however, we are greater than or equal to our target, but we want the minimal length, so we can actually start shrinking our window. So let's say while this sum is greater than or equal to our target, while it meets that condition, we'll shrink our window. And as you can tell, at this point, once we subtract the leftmost of 2, this now becomes 6. And now we no longer meet our condition. And that's okay, we do what we did before and we continue onwards. So now we're at 4. Once we add a 4, this is a 10. So once again, we have a satisfying condition. And here we also see that it is a 4. This pretty much just stays a 4. And then we do have, let's make sure we count that we do have a 10. So we start shrinking our window, remove the 3, this becomes a 7, which is perfect actually. And then this is 3. So this is getting a little messy, but now we have size 3, which is smaller than our current result. So that is minimaler than that. So let's account for that. And we can also shrink it once more. So let's see. We have this here. Let's pop that off as well. And now we have a 6. And left is now here. And no longer satisfy the conditions. So let's continue onwards with our pointer. Let's try that. Okay. So finally, we're at our last element. It is a 3. When we add the 3, we get a 9, which is greater than or equal to our target. And our left is currently here. So we have 3 elements. It's the same. We maintained the 3. And because this current sum is greater than our target, we can shrink our window. And now left, or the starting index, is where 4 is. Of course, we also want to make sure to remove the number we stepped away from. And if we remove 2 from 9, we get a 7, which satisfies this condition. And also the length is 2. So 5, the index 5 minus the starting index plus 1 for 0 indexing, that gives us a 2, and we have our minimal length of a subarray whose sum is greater than or equal to our target. Okay, so let's translate this to code. How would we do that? Well, what did we first do? We first defined some sliding window. Okay, so let's say that the start is 0, and we are iterating through the length of the entire array, so length of nums. And for r in range of n, we are saying, actually we can do r num of enumerate nums, so that we get both the index and the value, and then this is no longer required. Okay, we also want to keep track of the total, or the sum, total sum, and along with the result, or the min length. We'll just call that result. And the result, remember there's an edge case where we could have an entire array summed together which still does not satisfy the target. And so for that, we can set our base potential result to be float inf, such that when we exit this for loop, we can say return 0 if res is remaining as float infinity, as in we never found a minimal length that was summing up to or equal to or greater than our target value, then we return a 0. Otherwise, we return the result. Okay, so let's add, for each iteration, we're going to add our current number. And then, while this total, let's make sure we get that, while this total is greater than or equal to our target, we can say that the result is going to be the minimum of itself, or our current right minus L plus 1 for 0 indexing. Okay, so as long as we satisfy the condition, we're going to see if we can best our existing result and find the minimaler one for the result. And we also want to then close in our sliding window. We satisfy the condition, we want to start popping off from the left, closing in, making it smaller. So total minus equal nums wherever the start is, so that's L. And don't forget, we also want to move our window forwards. Okay, so we remove the left edge and we also moved it forwards. And at this point, we should be able to run and submit. Okay, so yeah, once again, this is 209 minimum size subarray sum. The main idea is to maintain a sliding window where you have a start, you maintain a sum of all the numbers that you're trying to add up to target, and as long as that total is greater than or equal to target, we satisfy this condition and we try to find the smaller range size. And whenever we find a smaller range size, we want to stress test it or stress it to find an even smaller number. And to do that, we keep closing in on our sliding window from the left, popping off the number from the total, making the total less, and also our window smaller. And eventually, if we find a result where some subarray satisfies this condition of summing up to greater than or equal to our target, we return that. Otherwise, we return 0. All right, well, that's it for today. Thanks so much. Happy coding. See you next time.